Welcome back. This is lesson 10a, where we are going to calculate limiting reagents by using the examples in the textbook. So on page 204, copper reacts with dilute nitric acid to form the copper 2 nitrate, nitrogen 2 oxide, and water. If 520 grams of copper is mixed with 466.2 grams of nitric acid, in a closed container, determine the limiting reagent. So we need the balanced chemical equation that was given. So we know that 3 mole of copper requires 8 moles of nitric acid. Now if they've given us a mass of 520,7 grams of copper, and we started off with 466,2 grams of nitric acid, what we should do is we should get the moles of each that we've got available. So the mole of copper is mass over molar mass. The mole of nitric acid is the mass over molar mass. So the mass is 520.7, and if you look on the periodic table, the molar mass of copper is 63.5 grams. And for nitric acid, the mass is 466.2, and the molar mass would be 1 plus 14 plus 48, which is 63. So the moles of copper we have is 520.7 divided by 63.5. That gives us 8.2 moles. And the moles of nitric acid is 466. Is that also 0.7? 0.2 divided by 63, so that gives us 7.1. It's 7.4 moles. Now we need to go to the mole ratio. The mole ratio is 8 moles nitric acid to 3 moles of copper. Now what I would do is I'd say 8.2 moles of copper needs 8.2 divided by 3 times 8 moles of nitric acid. So it's 8.2 times 8 divided by 3. It needs 21.87 mole of nitric acid, and I've only got 7.4 moles. So I have an excess of copper, and therefore the limiting reagent is HNO3 is the limiting reagent, and that will be used up during the reaction. So this is the limiting reagent. Now for the sake of space, I will have to delete some of these answers. Next, they ask us to calculate the mass of the excess reagent, that which does not react. So 7.4 moles of nitric acid, HNO3, will react. it will need, so 7.4 mole of nitric acid needs 7.4 times 3 divided by 8, which is 7.4 times 3 divided by 8, 2.775 mole of copper. So that is the mole of copper used. So the unused copper is the 8.2 minus the 2.775, which is 5.425. Now to change that into a mass, its mass is moles times molar mass, so it's 5.425 times 63.5, which gives us 344 and I'm going to round it off, 49 grams of copper that was not used. Next is the mass of water formed. For the sake of space, this must disappear. So it's the nitric acid's 7.4 mole or the copper's 2.775 mole that will participate in the reaction. I'm going to use the nitric acid to calculate the mass of water. So it's this 7.4 mole. The mole ratio is 8 moles to 4 moles. So this 8 mole ratio here gives us 4 moles of water. So all I have to do is I have to divide by 2 to get the moles of water formed. So that would be 3.7 mole of water, and to calculate the mass, it's moles times molar mass, so it's 3.7 times 18. 3.7 times 18 is 66.6 grams of water that will be formed. What volume of nitrogen monoxide is produced at STP? So for that, we need to know the mole of nitrogen monoxide is half the moles of water. So I need to make some space here. So the mole of water is, I need to divide by 2 to get the moles of nitrogen monoxide because of the ratio 2 to 4. So that is 1.85 moles. So if that is the volume, the mole of nitrogen monoxide at STP, we have this equation V over Vm that we can use to calculate the volume. So it's 1.85 equals V over 22.4. We can use this because it's at STP. So the volume is 1.85 times 22.4, which gives us a volume of 41.44 cubic decimeters. I'm going to have to do another presentation here to finish my examples.